Ever looked at the moonlit sky and pondered the origin of the Ma? Ever looked at the moonlit sky and pondered the originoon? This celestial marvel has fascinated humanity for centuries, serving as a compass for early navigators and a muse for countless myths. Moon is not just our closest celestial companion, but a significant symbol in cultural, scientific, and spiritual realms. It has shaped calendars, tides, and even Earth's biological rhythms. Yet, despite its pervasive influence, the moon's birth remains one of astronomy's enigmas. Was it birthed from the Earth, caught by our planet's gravity, or something more dramatic? To decipher this riddle, we must travel back to the tumultuous era in our solar system's history, billions of years ago. Imagine Earth, young and forming, about to experience a catastrophic event. This event, colossal in scale, would not only redefine the very structure of our planet, but also lead to the creation of its constant companion in the sky, the moon. Welcome to the story of the giant impact hypothesis. Once upon a time, about 4.5 billion years ago, the young Earth was not the calm and blue planet we know today. It was a place of immense heat and turmoil, frequently visited by other celestial bodies. Amidst this cosmic ballet, a planetoid about the size of Mars, which scientists have named Theia, was on a collision course with Earth. Theia, named after the Greek Titaness mother of the moon goddess Selene, collided with Earth with such incredible force that it literally reshaped the landscape of our planet. Imagine two colossal celestial bodies, each with their own massive gravitational pull, coming together in a fiery and violent dance. The impact was so severe that a significant portion of Earth's crust and mantle, along with parts of Theia itself, were ejected far into space. This debris, a mixture of rock and molten material, didn't just dissipate into the solar system. Instead, it began to orbit around the Earth, gradually coming together through the force of gravity. Over millions of years, this orbiting ring of debris coalesced and cooled down, eventually forming what we now gaze up at during the night sky, the moon. The creation of the moon wasn't just a spectacular astronomical event. This collision had profound effects on Earth itself. It is believed that the impact helped to stabilize our planet's axis, giving us the relatively stable climate we have today, and leading to the seasons as we experience them. Thus, the giant impact hypothesis not only explains the origin of our moon, but also illuminates how critical this event was in making Earth a habitable planet. This colossal impact not only gave birth to the moon, but also helped shape the Earth's tilt and stabilize its climate. What proof do we have of such a dramatic collision? Let's delve into the solid, tangible evidence that supports the giant impact hypothesis: the moon rocks themselves. When astronauts aboard the Apollo missions reached out and touched the moon, they did more than just make history. They collected samples that would become key pieces of a cosmic puzzle. Among the most compelling pieces of evidence are the isotopic compositions found in these rocks. Isotopes are versions of elements with differing numbers of neutrons. Remarkably, the isotopic signatures of oxygen, titanium, and several other elements in moon rocks are nearly identical to those in Earth rocks. This suggests that the moon and Earth share a common origin, lending strong support to the theory that the moon was born from a colossal impact involving Earth. The Apollo missions were not just about landing on the moon and planting flags. They were also about gathering these crucial samples, which have been meticulously analyzed to reveal secrets about our moon's violent beginnings. Scientists have spent countless hours in laboratories, using sophisticated techniques to study these rocks, piecing together the story of a time when our planet was not the quiet, blue marble we know today, but a place of immense chaos and creation. These rocks whisper the secrets of the moon's violent birth, echoing the chaos of the early solar system. But could there be other stories of the moon's creation? Indeed, the narrative of the moon's origin isn't confined solely to the collision of a Mars-sized body with Earth. There are, in fact, other theories that have sparked the curiosity of scientists through the decades. One such theory is the capture theory. This suggests that the moon was once a wandering celestial body that was captured by Earth's gravitational pull. Imagine a cosmic dance, where Earth with its gravitational charm lured the moon into an eternal partnership. Another theory is the co-formation theory, which proposes that the moon and Earth were formed together from the primordial accretion disk of the solar system. Picture them as siblings, born from the same swirling mass of dust and gas, growing side by side in the vast nursery of space. While these theories paint a fascinating picture, they have gradually fallen out of favor in the scientific community. The capture theory, for instance, struggles to explain the striking similarities in the isotopic compositions of Earth and the Moon. The co-formation theory, too, falters as it does not account for the high angular momentum of the Earth-Moon system. Despite their shortcomings, these theories have been instrumental in broadening our understanding. They have pushed scientists to ask more profound questions and to seek more precise evidence. While intriguing, these alternative narratives lack the compelling evidence that supports the giant impact hypothesis. Beyond its origin, the Moon has played a pivotal role in shaping life on Earth. Hovering in the night sky, the Moon does more than just illuminate our nights. It acts as Earth's celestial anchor, stabilizing the planet's tilt. Without this stabilization, our climate could swing into extreme seasonal variations, making it difficult for many forms of life to survive. The Moon's gravitational pull also orchestrates the rise and fall of ocean tides, a rhythm that has guided the biological patterns of marine and coastal species for millennia. Beyond its physical influence, the Moon tugs at the strings of human culture and curiosity. It has been a muse for countless poems, songs, and artworks, and a beacon for scientific exploration. The lunar cycles manage the biological rhythms of many creatures, including humans, influencing sleep patterns and behaviors. The Moon's serene presence and predictable phases have provided humans with a calendar in the sky, marking time long before the written word. Thus, the Moon's creation is not just a tale of cosmic violence, but also one of balance and beauty. So, the Moon we see today is a product of both cataclysm and serendipity. As we've journeyed through the cosmic tale of our closest celestial neighbor, we've unraveled some truly fascinating insights. Let's take a moment to reflect. We started with the giant impact hypothesis, suggesting that the Moon was born from a colossal collision between Earth and a Mars-sized body named Theia. This dramatic event, about 4.5 billion years ago, not only spawned the Moon but also reshaped our planet's future. Then we delved into the compelling evidence etched within lunar rocks. These silent witnesses, brought back by the Apollo missions, speak volumes. Their composition closely mirrors that of Earth's outer layers, lending strong support to the impact hypothesis. Moreover, we explored how the Moon's gravitational pull orchestrates the ebb and flow of our ocean's tides and stabilizes Earth's tilt, influencing climates and biological rhythms. Every time we look up at the night sky, we gaze upon a monument to the ancient and dynamic forces that continue to shape our universe. We hope you've enjoyed our journey through the Moon's epic tale of creation. If you found this video informative and interesting, please give it a thumbs up. Your likes help us to continue producing content that dives deep into the mysteries of our universe. We'd also love to hear your thoughts and questions about the Moon's origins. The comment section below is a space for you to share your perspectives and engage in discussions. Lastly, if you haven't already, please subscribe to our channel. We have so much more to explore together.